So before I start here, there will be no homework tonight. There will be no homework tomorrow night. I'm going to give you your choice assignment today, which is sizable.
Sizable.
There are 10 questions, no, 12 questions to finish, at least 10. We'll talk about them as I give it out. I'm just going to, as I give the assignment out, I have 3 changes I need to make to it. Not to make to it, but just that you're aware, because the font that I use is difficult to read. So I just want you for the limits to get the right numbers that I'm trying to say there, okay? So we're going to say find the derivative of f of x equals 3 over x plus 1. Okay, this question right here should be no big deal. Okay, I want you guys to feel good about this one. Keep your phones away, please, guys. This is starting to be very disrespectful to me. We've got a lot to cover here today. Okay, so if you do that, I'll be very happy. Thanks very much. All right, Brad, see my third student in the class. Can you give me the first step here, please? What's the limit statement, please? F find of x equals.
Limit which would be 0. X plus h minus, x plus h minus f of x all over 8.
Just so you know, Brad is my favorite student, but also everyone is equally my favorite student. Okay, so it's not like I like Brad more than everyone else. I like you all the same. So please don't be offended when I say that to you. Okay. All right, Callan, can you tell me what to write next, please?
37 your equation on top, so it'll be limit of h goes to 0. It's 3 over x plus h plus 1 minus 3 over x plus 1 divided by h.
Okay. Looking good? Caleb, what are we doing now, please?
We need a common denominator between those two.
Yeah, go ahead.
So it's 3 times x plus 1 minus the 3 times x plus h plus 1, which is 3x plus 3 minus 3x minus 3h minus 3.
Okay, just hold on a sec here. It's way ahead of me here.
Okay.
But I trust you, though. I'm just going to write down what you said. Now, after doing all these limits before, this should be not super difficult. All right, we've done this 100 times, not 100 times, a few times though now. So this we should be feeling generally good in our algebra skills. Is that somewhat agreed with, I hope? Okay, you guys are the smartest calculus class in Ontario right now, just so you know that. That's my opinion only. Okay, I can't actually say that. Okay, but I'm assuming that's true. Because this is really good you guys can get that. All right? All right, Teresa, what do we do now, please? Yeah, good. So it turns to 3x plus 3h minus 3x minus 3h minus 3. Whoops. 3x minus 3. Okay. Anybody here, not necessarily. Sorry, let me just write this out and then I'll ask my question. Not necessarily Austin, but he can take it if he wants. How do I know, looking at that we've done this properly? Like, what's like the visual cue, Austin, that I've done that properly? Yeah, like the whole purpose of these, remember, is that you want things to cancel, right? So if you have a 3x here, there's got to be a negative 3x. If there's a plus 3, there's going to be a negative 3. We're going to get into more complicated derivatives today. We're going to get into more complicated derivatives today. So that's just a number of things you need to see, right, that things should cancel. So this turns into lim h approaches 0, negative 3h all over x plus 1, x plus h plus 1 divided by h. Chris, why am I happy?
Because you can cancel out the h's.
Yeah, divided by h and h cancel out. So I'm left with lim h approaches 0, negative 3 all over x plus 1, x plus h plus 1. Since you weren't here yesterday, I'll skip you, okay? Yeah, right?
What do you do that next if we don't carry the limb all the way through?
Yes, you lose half a mark on that.
Even if we like say that
If we say
No, you have to. Okay, good question. The question was, do I need to keep the limit all the way down? Yes, you do. Okay, you lose half a mark. It's just good form, because otherwise, you have an H in here, who knows what's going on here, okay? You have to include it. If you forget and you just rewrite it at the very end, that's fine, I can live with that, okay? But please make sure, yes? Right on, yeah. And then at this point is when you sub it in, right? So you should get that f prime of x is equal to negative 3 over x plus 1 squared. Which is cool. Okay, I want to graph this even today, because that's how cool this is. Okay, so if you take a look, we started with 3 over x plus 1. You ended up with negative 3 all over x plus 1 squared. What does x plus 1 over x plus 1 squared look like? Did any of you guys do that last year? No? No, you didn't? Okay, you should have. But let's try it. Let me just say it out loud. Let me just say. Okay, so I'm going to do negative 3 over x plus 1 squared quickly here in Desmos, hopefully. Desmos. Tick, tick, tick. Okay, well, I'm using Internet Explorer, that's the problem. Sorry, Microsoft, if you're listening, don't take my job here. Okay, so my original equation was f of x equals 3 divided by bracket x plus 1. Is that right? What happened there? Okay, so if you take a look at this graph here, this is a neat one. There's going to be an asymptote here at x can equal negative 1, right? What's happening to my slope all the way along here? This is becoming more negative, right? It's starting like this, it's going more negative, 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 negative. What's happening to the slope on this side? Close. If it was coming more positive, it'd be going the other way. Because this is also going more negative. It's starting off as a negative slope, which is hard to see. It's more negative, more negative, more negative, more negative, more negative. So when we're saying what the graph's going to look like, negative 3 all over x plus 1 squared. Take a look. It's the same graph. It's a negative slope all the way, getting more negative, negative, negative. And I'll actually put the asymptote in here so it's easier to see. F of x equals x plus 1. Oh, maybe not. How do I do that? How do we just do x equals negative 1? How's that? So there's your asymptote, right? Is the green line. Okay, right? The graph's going to continue and then it's going to get negative. It's very neat. We're not responsible for graphing on your first test this year. Okay, this is just visually so you guys can understand what's going on here. Okay, right? Yes, sorry, go ahead. Yeah, for this you don't need to. I'm not going to penalize you for that in this one here, okay? The only time you would need to worry about things like that, or if there's word problems and you get, you know, an answer that doesn't work out, you know what I mean? Like, so if you're getting 3 answers, and one of them is negative 9, right? And that's going to be a problem, right? You can ignore that. Yeah. All right. Are most people feeling pretty good about this? Mostly. Okay. I want to take up one question from last night. Even though no one asked. Even though I want to ask this one, I want to take this one up because this is one that's going to be testable. So I want to make sure that everyone can get it or try it. It's 28. Would you like me to do A or B? It doesn't matter. 28A, sounds good. So this is page 62, number 28. Now it says use first principles definition. What that means is just the limit function that we've learned. Now this question doesn't look bad, but the algebra is going to be impressive. If you don't mind using the word impressive in algebra in the same sentence, okay? You will be required on your test to do something messy like this, because this is going to be messy. Okay, so there will be one like this. There'll probably also be a cubic or a quartic on there as well too, and we'll talk more about those today. All right, where did I stop here? I think I stopped actually at you. Can you give me the limit statement, please, for this? How far the X is?
H approach 0.
Yeah.
Okay. FX plus H minus FX over H.
Thank you. Okay? And again, I want to see that. I want to see that too, right? Just to present that. All right, Nicole, can you be very please and give me stuff some numbers in it for me? Go ahead. No, no problem. Luke, be brave, please.
I don't know either.
Okay, can someone help these two out?
It's X minus 1 for that?
Oh, sorry. Thank you. I even have the book in my hand and I can't get it. Okay, I'll do this for you guys. So it's going to be everywhere you see an X in the original function for you guys here, and X plus H is going to be replaced by it. Okay, so it's going to be X plus H plus 2 all over X plus H minus 1. Right, so it's the original function, right, and then just a plus 2 and then plus 1. And then minus, oops, X plus H, sorry, X plus 2 all over X minus 1 times, sorry, divided by H. Okay? All right, Derek, you're not getting off as easily as those two. Can you tell me the next step here, please?
Alright, the next step would be to combine the two fractions,
Okay, go ahead, please.
and that'll be x plus h plus 2 minus x minus 2.
Hmm? Oh, sorry.
Oh, Connor. Oh, I thought we were already there.
Sorry, I just didn't know what happened there, okay.
Okay.
I think it's okay, it's okay. It's okay.
Thought we were already past that.
No problem. I'm gonna divide by each, the whole thing is. All right, this is gonna be a big statement, so I think I'm actually gonna pause the video and let it roll. You guys just go back if you need to. You guys, what you have to do now is foil, okay? Now, as far as what you need to foil and what you don't need to foil. You need to foil the numerators, but not the denominator. Why do you only need to foil the numerators? What are you gonna do with the numerators?
Cancel the H and then.
Yeah, we're going to cancel, right? That's the whole thing. So the denominator, we don't need to cancel. So take a second to foil that if you're not done this yet. I'm going to pause the video because I'm going to go to 2 boards. I'm going to have to because this is getting to be a mess. It is crazy. Crazy stuff like this.